Hello everyone, let's look at Leetcode problem number 1992. Find all the groups of farmland. It is also today's POTD. So first let me understand. So first let's understand the problem. Here we are given a 2D matrix which is a binary matrix which contains ones and zeros. Here 0 represents a forested land and 1 represents a farmland. To keep the land organized, there are designated rectangular areas of hectares that consist entirely of farmland. These rectangular areas are called groups. No two groups are adjacent, meaning farmland in one group is not four directionally adjacent to another farmland in different group. I will come back to this statement if you didn't get it in the first go. Land can be represented by the coordinate system as it is a matrix. It starts from 0, 0 till n-1, n-1. Find the coordinates of top bottom right corner of each farmland and a group of farmland with top left corner at R1C1 and bottom right corner at R2C2. It is represented by this array. So we have to return a 2D array consisting 4-length array described above for each group. So there can be multiple groups in the matrix, and for each matrix we have to return this array. We have to insert that array in the 2D array and return that 2D array as our answer. So let's look at an example. So here we have an example. As we can see, this one here has no adjacent ones and one represents farmland, so it will be a group consisting only of this one as it has no adjacent ones. Then this will be a second group as it has adjacent ones. What we have to return here is the coordinates of this square and the last cell. So if we represent the coordinates, this matrix will be 0, 1, 2, 0, 1, 2. So for this group, we will have to make the answer will be the top left corner, which will be 0, 0, and the bottom right corner will also be 0, 0 as it has only one cell. For this group we will have the answer of the top left cell as 1, 1 and bottom right cell as 2, 2. Let me take another example to explain you the problem. So let's look at this example. In this example, if we see we have this group, and this group of farmland. For this group we will have the answer 0, 0 and the bottom right cell will have coordinates of 1, 0. Let me write the coordinates to understand it better. Now for this group we will have the answer 0, 2, 1, 4, and for this group the answer will be 3, 3 and 3, 4. So now let's look at the approaches to solve this problem. I was able to solve this problem using DFS, but it was really inefficient. Then I saw the solutions and I found the optimal solution, which I will discuss later in this video. So now let's look at the approach 1 of this problem using BFS. So in this approach, what I did was traverse the matrix, and as soon as we find a 1, we will call the BFS function over it, which will explore all the neighboring ones breadth-wise, and the last one which was found would be the rightmost corner. And while doing the BFS, we will turn the ones to zeros to mark them visited. So as we traverse the matrix, we will find here 1. We will flip this 1 to 0 and push this one in the queue. So this one will go into the queue, and in the next iteration this will be turned to 0, and as it has no neighbors, as it cannot push more ones, it will be our answer. As we know that DFS or that BFS goes breadthwise, so the last cell that was pushed into the queue would be the answer. That would be the rightmost corner. Let's look at this one. As we have flipped it to 0, we will push this cells and this cell in the answer. Then we move here, and now we again find 1. So we'll call the BFS function over it. Now this one will be flipped to 0, and it will push the neighbors, that is this cell and this cell, and this will be pushed into the queue and will be flipped to 0. Then this will push this cell and this cell, so this will be pushed into the queue and this will be pushed into the queue. Now this will be flipped to 0 and this will be flipped to 0. As this will be popped, now it has no neighbor which is or not already present into the queue or is 1, as this was pushed into the queue by this one and we flipped it to 0. Then we will pop this one and it will push this one into the queue and this will be turned to 0. Now we can see that this is the bottom right cell and it was the last cell that we inserted into the queue. So as we can see, the BFS moves like this, and the last push, that is when the queue got empty, this was our answer, that is the bottom right cell, and we'll push its coordinate, or we can return this coordinates from the BFS function. We will see that in the pseudocode. So now let me take an example of only one group so you can understand how DFS is functioning. So the groups are present in rectangular fashion. So as the BFS function will be called on this one, it will be flipped to 0. So this will become 0. Then we'll move to next to its neighbors. This will be pushed into the queue. This will be pushed into the queue. Okay, let me make a queue so that you understand it better. So 0, 1, 2, 3, 0, 1, 2. So here we have our queue. So firstly we will push 0, 0 into the queue. As we have pushed 0, 0 into the queue, these are not visited here, this will be popped, and while pushing the element, let's say we are turning it to 0, you can also use another number such as 3 or 4, any other number other than 1 to marking it as visited. 0 is not necessary here. We are just turning the ones to a different number so that when we traverse the matrix again, we don't find ones, so that the BFS function is not called on that again. Now as we have find 1 here, we have pushed its coordinate into the queue. Now we'll pop the first element of the queue, that is 0, 0, and we will explore all of its neighbors and push it into the queue. So now this is popped. Now we will push 0, 1 and 1, 0. Now we'll pop this 0, 1 from the queue. So now 0, 1 is our current. So now its neighbors are pushed into the queue, 0, 2 and 1, 1. As you can see that I am only pushing the right neighbor and the bottom neighbor of the current element. This is because we are doing BFS on the rectangular group, and if we are at any one, we have come either from top or the left neighbor, and these are already visited. As we are moving breadthwise, we don't need to push them again into the queue. So for any one, we will be pushing its right neighbor and bottom neighbor into the queue. So as we have discussed, we are pushing it and we are turning it to 0. So these will be 0 now, just so that we don't push them again. So now as we have popped 0, 1, we have pushed it neighbors this and this. Now we will pop another element. So 1, 0, 1, 0 have the neighbors 1, 1. Now 1, 1 is already 0, so we don't push it into the queue. We will, but this is 1, so we will have to push 0, 2, 0 into the queue. So now I hope you have understand why we are turning it to 0. Now we will pop 0, 2, and 0, 2 will have neighbor 3, 1, 0, 3 and 1, 2. So these are also pushed into the queue. Now we'll pop 1, 1 from the queue. I think 1, 0. Yeah, when we got this 1, 0, we have pushed 2, 0, but we have forgot to turn it to 0, so we'll turn it to 0. Now we have popped this and we will push this neighbor 2, 1 into the queue. 2, 1 will be pushed into the queue, and then we'll pop another element which is 2, 0. So now 2, 0 will be popped, but it has no neighbors that are ones. Either this may be out of bound or it is just a part of matrix, so it might be 1, it might be 0, so we don't consider here. So if we go out of bound or if the neighbor is 0, we don't push it into the queue. Now I hope that you have understood this. Now this will be popped and this will be pushed into the queue, and while then we will pop them again, and when we reach the last element, our queue would be empty, as this neighbor would push this one and this neighbor can't push it, so it will just be popped. So all of these will be popped from the element, from the queue, and last we get this answer. So from the BFS we will return 2, 3. Let me move to the pseudocode of this problem so you understand it better. If you haven't understand it well, it's not a problem till now. Now let's look at the pseudocode of the BFS approach. So first we'll have the find farmland function. Find farmland. It has a parameter land, which is the 2D matrix. Now we'll have to make a 2D matrix which you have to return as an answer. So we can, in C++, we can make a vector int. In Java you can use the array list. Now we'll just traverse the matrix land for I in row, for j in column. Now if we find the current element is 1, so if land I j is equal to 1, so we find a 1, so that is we find a new group. For this group we will call the BFS function, and that we have to make a vector which will store the coordinate of the current cell, because that is the top left corner of the group. So we'll make a vector. You can name it as a temp answer or current answer. I will name it as vec, and initially it will have I, j, which are the coordinates of the first cell, that is the top left cell. For example, if we see this group, we find this one, so we will have to push these coordinates in the vector. Now we will call the BFS function, which will give us the coordinates of this one. So let's say we are using a pair here. So pair int comma int p is equals to bfs on land I j. Now, as we have gotten these coordinates, we have to push them to our vector. So vec dot pushback p dot first and vec dot pushback p dot second. And now finally that we have answer for this group, we must push this answer to our answer vector. So answer dot pushback, we'll say vector, and now we'll continue the iterations for next group, and finally we will have to return the answer here. So let me make these brackets. So we will here return our answer. So that's our farmland function. Now let's move to the main function of this approach, which is the BFS function. So as we have seen that the BFS function is returning a pair, so its return type should be a pair of int let's name it BFS. It will have land, the coordinates of the top left one of the group, so as we are doing a BFS, we will have to make a queue. So we'll make a queue pair int so initially we'll have to push the queue with the top left cell. So queue dot push I and j. You can use the make pair function here. I'm using the curly brackets because it's more convenient. Now as we have discussed, we are going to mark this as visited as we are pushing it into the queue. So I will discuss later why. So land I j is equals to 0, and now we'll start our loop. So while our queue is not empty, what we will do is pop one coordinate. So we can say pair int current is equals to q dot front. You can access the coordinates by current dot first or current dot second. For convenient, I am making variables int current x int current y is equals to current dot first and current dot second. So now that we have the coordinates of this function, also that we have to pop the queue. So q dot pop, and now we'll mark the current coordinate that we just popped as visited. So land current x current y. No, actually we don't need to write that line here. I don't know why I have written it in the code. So let's comment it. Now we will check the neighbors. So first we will be checking the right neighbor. So the right neighbor will be the right will be current x and current y plus 1, but as we are checking the y plus 1, it might go out of bound of the array, so we need to check it. So if current y plus 1 is less than land of 0 dot size, as you are checking the columns here, so land of 0 and land of current. Okay, so this won't come here, let me write it below. Land current x current y plus 1 is equal to 1. Then we'll mark this as visited first and then push it into the queue. So land current x now pushing it. So this is a pair, so you can again here use the make pair function or the curly braces. Similarly, we will check the bottom neighbor. So if current x plus 1 is less than land dot size, as this might go out of bound, and land of current of x plus 1 and current of y is equal to 1. Now we will mark this as visited. So land of current x, it will be current x plus 1, current y plus 1 is equals to 0. Now we'll push it into the queue dot push current x plus 1 current y. So now as we have pushed the neighbors, we will close our while loop here. So we'll close our while loop here. So now we have done the BFS, but our answer would be the last pushed current value, as this won't push, as the right bottom cell will not push any neighbor. As we can see, this goes out of bound and this is 0, so it won't push anything into the queue at the last. So this will be our answer. So what we will do here is, instead of defining this current here, we can actually move it upwards. So what I will do is define it outside the loop and here, and now we will just update the value of current here, and after we have completed the loop, we can return the current pair, and that will be a BFS function. The thing is that it's inefficient because here we are traversing all the groups again as we traverse the matrix. So now let's move on to the optimal approach of this problem. Now let's look at the optimal approach of this problem, which is leveraging the fact that the first cell of any group will not have the top cell or the left cell as 1. As we can see, for any other one in the group, either the left or we can say the upper cell will be 1. So, and also for we're using the fact that we used in the previous approach, that this bottom right one won't have a 1 on its right or bottom side. So now let's see what we are doing here is in the find farmland function, we are traversing the matrix, and as soon as we find 1, for example, while traversing the matrix, as soon as I get 1, I will traverse it to the rightmost column. So here it has only one column, so let's look at this example. So as soon as we call the function on this one, we will go to its rightmost column. So let's say this is I, will move I to here and then I to here. As soon as we are finding 1 or we find end of the matrix, we'll go here, and now we will move to the bottom row as soon as we are finding 1 or we reach to the bottom of the cell. So we will get here. So what we are doing is, as we find a 1, we go to the right side and then we move to the bottom side, and the last cell will be our answer. So let me show you another example. So let us assume this is our matrix 0 0 0 0 0 1 1 1 0 0 0 1 0 0 0 0. So now as we traverse the matrix like this, we'll find 1 here. Now we'll call the function over it with parameters I and j. So we'll move to right, we'll move I right until we find 1. So I will be here, and now from here we will move to the bottom of this cell until we find a 0, or we find end of matrix. We find end of matrix here, so we must stop j here. So as we can say that we have this j now and I is here. So actually in the functions, as in the previous approach, we are using I for the row. So this won't be I, this will be j. We will move j to right, and then we will move I to here, I and I. So now as we can see that we have reached the answer, we will return this ij as a pair. So what we'll be using instead of BFS here is a function get coordinate that will give us an answer with constant space, as we are not using q here, and we are also not traversing whole matrix. But the problem here is that as we are not turning the ones to 0, we need to identify the top left one, that is this one and this one, as these will be the starting cell of the group. So for finding this, we are using the fact that for the first cell of the group, the left side of it will be either 0 or left, or as we can see here, out of bound, or the upper cell would be 0 here, as in this case, or out of bound here. So let's move on to the pseudocode of this problem. So now we will move to the pseudocode of this problem. So we will have a function find farmland, which, like the previous approach, we will traverse the matrix. So let me just copy it from there. So find farmland, we will be making changes in this find land function. So what you can, where we are going to make changes here, that we are finding 1 and we are calling the BFS function over it. Here this condition will be changed, as we are not going to find 1 here but the first cell of our group. So actually this logic would be same. So let's keep it. I will copy it. The video is already going to be long, so copy. Now we will change the if condition here. So the condition should be if land I j equal to 1 and we will now check the top cell, the above cell of this ij. So if I minus 1 is less than 0, that is, if here, as we can say, it goes out of bound, or here we can this should be 1, why this is 0, this should be 0. So now let's see this one. So above it would be 0, so either it goes out of bound or land of I minus 1 and j is equal to 0. So now, as we can see here, I am not checking out in this we are not checking out of bound, as if this condition is true, it will move inside and not check this condition, so it won't give us a runtime error. And now we will check the left cell. So if j minus 1 is less than 0, or land of I j minus 1 is equal to 0, that is, either the left is out of bound or the left cell is 0. So now this will be our condition, and inside this we will move the logic of our previous question as it is. So let's move this a little bit down and now paste the logic that we have copied. So we will again make this vector. Then instead of calling the BFS function, we will call a function get coordinate. So let's change it get coordinate, and it will have land I and j. So now let's move on to the pseudocode of get coordinate function. So moving to the pseudocode of get coordinate function. So it will also return us a pair of int get coordinate. It will have parameters as land I and j. So now what we will do is, while we'll move I to the right side until it is 1 or it goes out of bound. So while I plus 1 is less than land dot size and land of I plus 1 j is equal to 1, as the I is inside bounds, so this is checking inside bounds of the array land, and still it is 1. So we will move to the right side in the while loop. We will just do I plus plus. Similarly, as first we move to the right side, so I was first here, then it will move here, then it will move here. So now we have to move j to bottom. So what we will do here is, while j plus 1 is less than land 0 dot size and land of I and j plus 1 is equal to 1, we will increment j, so j plus plus, and here we will return make pair I comma j. So this will be the coordinates of our bottom right cell, and these values will be returned here in this p, and then p will push back the first, that is I and j, the calculated I and j from the function, to the vector for all ones or for all first ones of the group using this condition, and that will be our answer. So thank you for watching the video. If you have a better approach to this problem, use the comment section and tell me. Okay, so till then, bye bye.